Hello. Thank you all for coming along. As was said, I'm a QA engineer at Focusrite. That means I work on the Novation team primarily, and that means most of my life revolves around testing things. It's mechanical, electronic, firmware, software, my colleagues' patients, all kinds of stuff like that. Here to talk some testing with you. First thing, we're going to talk testing is understanding your goals with testing. So you need to be clear about what you're setting out to do. When you make something, hopefully you have some goals. You could be, I'm making this function, I want it to convert a linear gain to a dB value. Or it can be, I'm making this synth, I want it to be the sound of a generation and bring us acclaim and wealth. One of those is slightly easier to test directly than others. But it's important to keep your high-level goals in mind when you're testing things, because if you focus too much on the small things, then you end up in kind of situation where you've spent months and months making really nice text boxes, and the text boxes only appear in two places, and you're never going to finish. Hopefully, if you focus too much on the big things, then you slap together a bunch of odds and sods and end up with something that's massively unstable and falls apart whenever someone says strange things to it, which definitely happens. So, go first. I want to cover some kind of key terminology when it comes to testing, and one of those is coverage. So, coverage comes up a lot, and it can be slightly nebulous to define. So, it's generally referring to how much of what your thing can do are you testing. So, let's look at an example. Recognize this as Fizzbuzz. It was an incredibly boring kids game that became a bit of a programming personality test. Typically the rules are you count up numbers. If the number you're on is divisible by 3, you say fizz instead. If it's divisible by 5, you say buzz instead. If it's divisible by both, you say Fizzbuzz. I've swapped out the 3 and 5 for variables. So how many tests do you think can run on this? What's that, about somewhere between 15 lines of code, something like that? Well, we've got two 64-bit ints as arguments, so that's 2 to the 64 squared possible ways to run this code. If you do one of these a millisecond, that's about 10 to the 28 years. That's slightly longer than the length of the universe, slightly longer than the average agile sprint. And that's just for like the smallest bit of functional code that does anything of note. So scale that up, try and get high coverage on your project. You can't. Your coverage is 0. Whatever you do, your coverage is 0. There are tools that will look at your code and they'll see, have you evaluated everything as true and false? Have you gone down every part, every branch, every path through your code? Has everything been run in a unit test? And they'll give you a score and they'll say, you've got 100% coverage. You don't. You have 0% coverage. You always have 0% coverage. Those are good metrics. I think those tools can be useful as long as you don't fall for the big numbers, because really you can't just say, I've run it all. Obviously, it's all perfect and fine and it's never going to break or do anything weird. Thing is regression. Another word that comes up a lot around testing. As a noun, a regression can be something that was working but has since broken. So these come up all the time and they're incredibly annoying. Once you've got a lot of complex systems interacting with each other, there's going to be things that, I changed this over here, but I didn't look at all the places where it connected to, and now something's trying to use an old version of this API, or we've not updated this variable in every place it has to go. We've defined something twice. So this is something that you are going to have to fight, but it's also one of kind of the key points of writing kind of high code quality code, is trying to battle regressions, because if you know you've not defined things in multiple places, you've not kind of had things that interact in strange ways that aren't very clear and kind of are reaching out, that's one of the kind of preventative measures you can take against regressions. Regression, it kind of also gets reused for the idea of a regression test. So that will be So we're pushing out a big update, test everything. Try and go as many different things you can do with this. You've still got zero coverage, but try and track down as many of these little weird things that might have slipped through, and get confidence that, right, this is a release build. If we send this out, we're not going to immediately get half our customers having complaints that we've broken things. We're still going to miss some, but it's kind of the best effort to try and quash these things. Right, breaking it down. So there's lots of ways you can kind of classify tests, split them up, and go through a few. Pretty much every test will fall into one category for each of these, and there are other ways you can go. The important here is that none of these are one is better than the other. Perfect testing requires a good balance of all these different types of tests to kind of get to make sure you've looked at the things that might be happening. So quantitative and qualitative, apart from being very difficult to say, it's one of the most fundamental divides in testing. Some of you may have done it at school in science classes, depending on what education system you went through, but yeah. So you've got quantitative tests. These are ones where you can take a measurement. You can quantify what you're looking at. You can plot the results on graphs and excite your managers. You've got pretty pictures. You can kind of get a number, see if you measure up to your goals or to your competitors. Qualitative tests are the ones that are a bit more subjective. You might not be able to quantify what is good in this situation, but you know when you see it and you feel it. So maybe something like a key mech in a keyboard. We can take a bunch of measurements from that, but really what we want is for it to feel good when you're kind of jamming out on it. Yeah, again, if you're kind of doing a synth, there's loads of ways you can measure a filter, but what you really want is something goes blah in a kind of satisfying way. So yeah, it kind of depends what you're working on. If you're doing kind of very technical things, you're probably going to lean heavier on the quantitative. If you're doing kind of more artsy-fartsy things, you're going to lean a bit more heavily on the qualitative. Depends on what your customers are going to be looking at. It's the kind of thing where first thing your potential customer goes to is the spec sheet, then that's where your quantitative results land. If it's going to be something where they go into a shop and poke things, that's going to be qualitative assessments that they're making if they're going to decide to buy your product, in which case you probably need to make sure that your qualitative aspects measure up well. Unit and end-to-end testing. So unit testing generally, and people in this context will think of this kind of pure software unit tests where you isolate a little bit of code and you wrap that up. You can also do it with hardware. You can say, right, I've got this chip. I'm going to have it on this dev board, and I'm going to poke it in all the ways I can. So yeah, so you're kind of isolating a small part. Could be a class, could be a function, could be a component. Principle here is if you take a bunch of known good parts, plug them together, then you end up with a known good whole. That is also not true, because there's going to be problems plugging them together, but it's a good starting place. If you can kind of identify that this works, this works, this works, then it's those connections that are going to be kind of potentially flaky stuff. Yeah, they're also really useful because if you're running a unit test and it fails, then you've only got a fairly small kind of thing to look at to kind of identify where the problem is. If you're only testing 100 lines of code, that's much nicer than having a problem when you're testing several thousands in a completed product, or you've cooked up everything together. The key tools when you're unit testing is called mocking. So your unit is going to be connected to other things once you've got your fully assembled product. That can be something like it's connected to a database. It can be I'm plugging my keyboard into some other controls to have knobs and pads and stuff. Can be just this is going to get called by other bits of code. So if you want to test it, you need to kind of mock up things to fill those plug sockets to go together. You want to write kind of the simplest thing that will take up that space. So instead of trying to run your tests connected to the database of all your customers' information, you can mock up a fake database that's got like you and a couple of mates having some information that you can pull down and say, right, I know exactly if I look for this, I should get this. You can say, right, I'm not going to actually read the ADCs. I'm just going to have a thing that says, once you call this, return 7. And then you can kind of test that that's getting through the system as you'd expect it to. If you're doing things with audio, you can kind of mock up WAV files rather than trying to do live input, because that's always going to be more complicated. Yeah, and yeah, as I was saying, dev boards for electronics, you can plug them together, make something, a dumb version of what you're actually going to be plugging things into. End-to-end tests. So the other end-to-end is once you put it all together and you've got your whole product kind of from start to finish, you want to test the whole thing that you're going to be shipping to customers, and you want to check that it all works, because as you say, you can have known good parts, plug them together, and they don't work properly. Yeah, it's important to kind of test the representative thing and not get stuck in the idea that, right, I've tested this all in parts, it's going to work, it's going to be fine, because once you scale things up, so we're not just running one voice, we're running 16 voices of the synth, but if we only tested it on one voice, then we didn't realize that it scales badly. These things try and conflict in memory, or they kind of run out of memory on your system. You need to test the real thing at some point. Moves. Slight digression for end-to-end testing is test hooks. So basically, test hooks are ways of interacting with your product that aren't user-facing. So they're just ways for you to kind of, for your testing, you can set things, get things, kind of interact with things. So a lot of big software might have like a full-on console interface where they can call whatever they want. You'll see video games that'll let you teleport around the world if you type in the special words. Innovation, we have a whole bunch of secret MIDI sysx messages, because through sysx all things are possible. It's kind of, these are things that go into the released product. So there are secret messages you can send to your Novation products to light up pads and do all these fun things that are not at all fun to anyone except QA and factory test people. And yeah, they're very useful to have these kind of things, because they get you end-to-end testing without being reliant on user interactions. Because if you have to manually press through every button, that's going to be a bit slow, it's going to be awkward. But yeah, you've got to kind of have that connection. Sometimes you can split them out, have specific debug builds that have these hooks that don't get released into factory. Sometimes you have to do that because of security things or licensing things if you're using special libraries to do it. But in general, if you can leave them in, it's generally a good idea to have it be as representative as possible, and kind of have that real world testing of the final product. Scripted and exploratory. So scripted testing can be the software sense of a script. So a kind of self-contained bit of software that is kind of going to run. It's not going to take any input. It's just going to give you a result out the end. Or it can be in the kind of sense of script as a list of instructions that you give to a person. So it can be a script for an operator to follow through. And you'll say, press this, press this, press this. Is this doing this? For your end-to-end things. So scripted tests are really good because they're repeatable. If you run a scripted test on one thing and it works, you run it again, it doesn't work, you've broken something, ostensibly. So assuming the test has been run right and written properly, that it is that kind of thing, then you can kind of say with a fair amount of confidence when something's got broken. Yeah, they're also the basis for performance testing. We'll get to that in a moment. On the other side, this is exploratory testing. So you've got to use the thing. So you can't test everything, and dealing with a scripted test, can be quite a slow process. You've got to define, right, this is what we're going to do, this is what the expected results are. This is kind of how you do it step by step to kind of have that perfect repeatability. But sometimes you just need to kind of go through a lot of stuff, have that fast feedback cycle of saying, right, if I do this, this works. If I do this, that's fine. Actually, if I do all these things, then that's not fine. So yeah, using the thing, trying to find those little edge cases that maybe are a bit awkward to define, or if you try and define them, you just never stop, because it's kind of saying, okay, this is kind of worth doing and this is too much. Actually, just try and explore what you can do. It's not just for kind of fully built products. You can do exploratory testing on code. So you can say, I'm a big fan of Jupyter notebooks, or you can build like a little CLI that'll let you kind of run real-time code. Some languages have native REPLs, read-evaluate print loops, read-evaluate process loops even, that essentially let you run your code in real time, explore what it does as you're running it. Automation. Going on from scripted tests, I'm not going to talk too much about automation. It's a whole talk on its own. Talk was given last year by Joe Dalla and Jake Wignall, so look it up on YouTube. But briefly, if you can get a computer to run a bunch of tests for you without requiring you to have any user input, that's very convenient. If you've got like software unit tests, those almost always are going to be automated. You're going to have one of the key steps of moving from just having a compiler to having a build system is something that will compile and run your unit tests for you, and kind of that's where you get into continuous integration, stuff like that. You can also automate end-to-end. We're talking about test hooks. As much as they're useful for manual testing and poking things, also means you can put them in a software script and run them, kind of plug them into each other. And this is something that you can do at kind of various levels of scale. So at Focusrite, we have a cupboard full of Scarlets that are all hooked up to Mac Minis that are constantly testing things without having to spend an awful lot of human time pressing buttons and twiddling knobs and listening for glitches and stuff like that. But you can also just have a couple of Python scripts that you run at the end of the day, and when you get back to your desk in the morning, it's got a bunch of test results for you. See if you can, does it fall apart if you run it for 16 hours while you're asleep, or run it for a weekend while you're doing other things. So yeah, automation, incredibly useful. So the trio, feature validation, performance testing, and compatibility compliance. So feature validation, some things they work or they don't work, or they sometimes work, or they work unless you put them in this context. You can certainly write script tests for feature validation, but once you pass a certain level of complexity, it can get quite difficult, as the amount of potential interactions between features in your product kind of grows exponentially as you get more features. So generally, you're going to be leaning quite heavily on exploratory testing. Sorry. The other thing when you're doing feature validation is not only testing against your spec, because hopefully you've implemented this feature, you've had a spec for it, you've had some requirements that this feature was trying to meet. Does it meet the overall goal once it's implemented? So it's all very well to say, right, we think if we do these things, this should kind of achieve this thing for our customers. But the difference between theory and practice is greater in practice than in theory. And sometimes it takes kind of building the thing to realize, actually, this isn't achieving what we want it to achieve. It might be meeting the requirements we laid out, but actually that doesn't meet the overall goal of making a cool product that people are going to want to use and is going to help them and bring joy to their lives. Performance testing. So some things don't just work or not work or sometimes work. Some things work to varying degrees. So performance testing is the other side of where you're generally going to lean heavier on scripted testing. You want to be able to repeat the same test, make a modification, see if these things are improving what you've done, or if they're kind of making no difference or making things worse. And you need to be able to quantify that. You've also thinking about what you're testing to. So it could be a spec that you've defined, it could be you're benchmarking some other product, saying we want to perform better than this or at least as good as this thing. So in that case, you want to have a scripted test that is portable between different products. You don't want to be relying too much on things that are exclusive to you, your special test hooks that only work on your products. Sorry. Yeah, so yeah, the other option is subjective approval, in which case you might be able to get away with a less scripted test because you're kind of gonna see if this is good enough. Do these knobs feel good? Are they performing well enough to kind of go for it? But it's always worth getting some perspectives when you're doing that. It can be very easy. If you're the one working on optimizing this performance, then you say, that's good enough, I'm going to stop and do something more interesting, in which case you probably aren't there. So it's worth getting a few people, having a play, direct comparisons with other things that are doing that, your competition, your previous products, and hopefully being able to quantify that approval level, even if that's after the approval's done. So instead of saying, right, I'm going to say we need to hit this to approve it, we're going to say, we're going to fiddle with it till it feels good, and then we'll measure what it does and say, right, at no point should we regress below this performance level. This is what we've established is good enough now. Compatibility and compliance. So I've kind of squished two together here. So compatibility is generally working with other things. Most things don't exist entirely unto themselves. Even things that kind of have standalone modes generally will have some compatibility. Like our circuit products, they can be used standalone. We've got batteries and things like that, but they've also got a bunch of I/O if you want to connect it to other things. Our MIDI controllers, they work in standalone modes, but they also have these custom integration scripts with different DAWs to try and give you these smooth working together of your hardware and your software. Generally, if you can be compatible with a standard, that's quite a lot nicer because you can say, right, I'm doing exactly what I should be doing. If something breaks, it's definitely their fault. Whereas if you're relying on something custom, it can be a bit of a balancing act, a bit of diplomacy to see where things need changing, if things kind of break in the future. The ideal thing for kind of testing compatibility is to have a matched pair of tests. So you'll say, right, I'm going to draw a line here, my side is here, your side is here, write a test. If I meet the requirements of this test and you meet your requirements of this test, then we know we're talking the same language, we're communicating the way we expect to communicate. That's kind of the ideal, whether it's always as practical, because it can be quite complicated. But yeah, you want to kind of mock up the other side of your compatibility line. The other thing for compatibility is things like OS compatibility. So most of what I work on is embedded stuff, but if you're working on desktop software, then how many versions of Windows do you support? How many versions of macOS do you support? How deep a hole do you go into with Linux? Do you just completely avoid it? It can be a difficult line to draw. You want to be compatible. You also want to not be debugging every customer's weird Windows 98 system that they refuse to move on from, because there are people out there who have the strangest setups. If you can get stuff automated, then that takes a lot of headroom on that, because that's one of those situations where you want to be running these same scripted tests every time on every platform, so you can check they all perform the same. Again, that's much nicer to have that automated than to have that as a manual process. You've also got beta testers that come in useful there. Get to more of them in a moment. Compliance. Generally, when we're talking compliance, we're either talking about the bigger standards, so like USB, or we're talking about kind of laws or regulations. Last is more of a thing in hardware. We're going to make a product, we have to certify that it's not got a bunch of crazy electromagnetic radiation. It's not going to be a problem if someone with a pacemaker walks up to it. That would be bad. Yeah, we have to make sure that we've made it out of really sensible things. We've not got kind of suspicious suppliers who are doing sketchy stuff. Some compliance testing is kind of very specific, can only be performed by kind of certified third parties. You have to take it to a test house and have someone else external to your company sign it off. For the less stringent ones, they will be very scripted. So one we do USB compatibility compliance is a computer with a special USB card that will run through special tests that prove that we're being a good USB device. And again, that's something where once we pass that, we know that any computer that's passed the be a good USB host tests, we should be able to work with that. We should all be fine. We can kind of confirm that our USB implementation is up to scratch and is doing what we want it to. Tools. So now we've done categorizing our tests. What tools do we need to run them? So if you're doing kind of full product exploratory end-to-end testing, you probably just need the product and, I don't know, maybe a computer to run it on if it's software. But if you're doing unit testing, so in software land, there's various unit testing frameworks. C++, there's things like Catch2 and Google Test, and there's one in Juice as well. Rust has one in Cargo. Python has a bunch of stuff. Dealing in web things like Cypress and Playwright. If you're dealing in hardware world, there are kind of things like oscilloscopes, which are very useful for running tests on electronics, because that's essentially a standardized tool for testing electronics. Logic analyzers, stuff like that. If you're going to try being compatible with standards, there's probably standard tooling out there. You're saying about the USB thing, that's very standardized, for the sake of consistency. But for other things, there's kind of bits and bobs. We get kind of MIDI monitors that check that your MIDI is properly structured. There's always a bunch of tooling for products that other people have had to problems that other people have had to solve on their products. But eventually, you're probably going to have to run into a situation where you make your own tools. So your product is doing something special, hopefully. Otherwise, it's probably not going to do very well as a product. But you're going to have to kind of take your own measurements, make your own tools. That's something we do an awful lot. So whether it's kind of tools to integrate with those hooks that you put in to make your life easier, whether it's custom measurements that you want to take, that's something we're doing basically all the time, is writing a little tool that's in PD or Python that will send messages to a device, take messages back, it kind of excite it in certain ways and see if it's doing what we want. Sometimes that can be something that's really reusable. So it'll be like Novation standard for how we do these things. We run it with this tool. Sometimes it'll be this very specific feature on this product. We need to make a custom tool for that. And it'll just kind of live there and be the tool you use to test that very specific thing. Generally, when you're making these custom tools, you want them to be as simple as possible. The last thing you want is to think you're seeing a problem in your product when actually there's a problem in your tool. So that's kind of why we use a lot of the high-level tools like PD and Python, because if we're dealing with memory issues on our tool, then we may or may not either mask or kind of flag up memory issues that are actually our problem as opposed to the product's problem. What you shouldn't test. So you can only test from your own perspective. And if you're the kind of person to come to an audio development conference and attend a talk about testing, that's probably quite a technical perspective, to be polite. But yeah, that's generally not going to be representative of what you intend your customers to be. Sorry. Not to mention that once you've been working on a product for months or years, you can't approach it objectively. If your first sight of this product was the little demo juice window that appears because you checked to compile it from that template, then you don't know what the first impression of the actual product is. You know its guts too well. So that case is something where you're going to want to get beta testers. Getting a group of people who are more representative of your user base, kind of they don't have that built-in bias getting their feedback on it. One of the tricky things about beta testing is when you get them involved. So if you wait too long, then it can be difficult to make significant changes. So if you say, right, we're getting beta testers in now, but we've already committed to all these things, then if they say, actually, those things are bad and you should change them all, then you're a bit stuffed because you can't just rip everything up without having kind of major impacts on the schedule and stuff like that. The other issue is if you bring them in too soon, then you risk kind of removing that objectivity. That same thing where they've been using this too long, they've got used to this kind of fudgy workarounds you put in for early stage development, and they're no longer representative of your customers. The other thing to talk about on what you shouldn't test is accessibility. So people have different accessibility requirements to make things usable. Hopefully you've got your accessibility features in, but who's going to test them? So I walk with a stick. If you ask me to test the Dance Dance Revolution, I can probably point out some problems, but I don't use a screen reader. We've got screen reader support. I can turn it on. I can probably tell if it starts swearing at me, but I don't know a good screen reader implementation from a bad one. So it's very important when we're dealing with accessibility, you get the right people testing that, because again, it's a matter of perspective. If you don't use these tools regularly, you don't really know what makes them good. These subjective sign-offs, even if you've matched your requirements for these things, that subjective, is this actually achieving our goals question, is something that can only be really answered by someone who's really going to be using these tools. Security. It's a little specialist subsection of testing is security. So there's going to be security implications in a lot of things. For example, what we do, we make USB devices. Got to think, right, is there any way that someone can program this behind your back and secretly make a keylogger or whatever, make it some suspicious thing? Because we can update from a computer. Can we make sure that it's not updating into something bad? Also security implications of IP. So we've done something very special where we've got these wonderful bits of firmware that are legally protected. You don't want that showing up on an AliExpress special that's got all the features of our product. We want to kind of keep that secure. We'll see how we can get there. One of the biggest security risks, though, is when you're making something connect to a database with kind of people's personal information in it. So that's a kind of one of the biggest problems you can have is, can your product accidentally put people at risk? It's kind of data breach in that kind of context, but also there may be other risks, kind of physical risks for hardware products. Other places where there could be problems. It's very much a specialized area. People who work on this are called pen testers. If you're relevant to what you're doing, hire one, because this isn't something that you can just walk up to. It's a evolving field of cybersecurity, and preferably don't make your products involve that because it's really annoying. How far? So I've been talking. I work at Focusrite. We're a big company. We've got lots of resources to cover all these different kinds of tests. We've got an automation team. We've got a whole bunch of people. If you're not at that level, what can you do? So one thing I'd warn against is kind of skimping on testing, because I don't need to go that deep. It'll be fine. I've got my software unit tests and I'm happy, because that's going to be the kind of thing where you end up with a weird bug that you could have caught earlier, and now it's really embedded in your code structure. So if you want to find the bugs, you've got to put in the F in testing. Also, you don't want to be leaving these things for your customers to find, because that's going to be, if you get the reputation as the people who release the buggy stuff, that's a hard one to shake. If you don't have the resources to run a full-on beta program, maybe you can find a couple of friends who'll try it out for you, even if it's kind of You've written it all on Mac. Does it work on Windows in the slightest? Well, ask your mate. Let them run it through. See if it makes sense to them. See if it works on their system. You don't have the kind of resources to build a full-on console interface into your thing for test hooks. Maybe you can put in a couple of keyboard shortcuts that will pop up some metrics about how your prompt is doing, how your code's running. If anything strange is happening, you can visualize that. Ultimately, the goal we're having here is to make products that people enjoy. And so we need to make sure that UX is sensible, that these things are reliable, and the way you do that is with a good amount of coverage on tests. You need to get it in front of people, get their feedback, get it kind of stress tested, see these things kind of working, see it all in action, see how it goes. That's right. Any questions?